All right, so first thing is we're recording call. Problems on PA4. Problems on PA4. Almost kind of Q&A.
Still stuck on.
Yes, the answer is yes, there's problems.
Yes. I'm stuck on test 5. I feel like there's a lot going on for me, and I was gonna see if you could stay after for a bit.
Nope, I go like the wind.
Cool.
They, we have office hours, we also can do Skype, and Skype we can do on this, but see the tutor, but you're starting to run out of time. I can't emphasize enough that this is a shitty assignment.
Oh, I know.
So
Yep.
so we'll see how far you get.
I got a question real quick.
Yes.
So for coalescing,
Mhm.
if the test fails, but the coalesce is correct. So like if it fails on linked list as opposed to coalescing,
Can't.
it can't.
Well, let's just like, are you saying the test is wrong?
Oh, no, what I mean is like if you fail the test based off your linked list, but now you coalesce, like if your coalesce is correct, you get points for coalesce or you're just not there.
Oh, okay, they're talking about the grading.
I'm sorry about
Yeah.
that.
So you can't, we can't check coalescing unless you pass test 16.
All right.
That's where the coalescing's at.
Alright.
So so you'll probably get it already working to do this stuff. So anybody, first of all, anybody done so I can show you how to grade? Fantastic. Let me grade. Show you how to do the grading for.
Are you about to turn my code a new one?
No, I'm not doing, I'm just gonna show how I'm grading it.
Okay.
No,
You should.
it's actually not right to show like code review while people are still doing it, right?
Oh, sure.
Because others like, why did you do this line? Because people will screen grab, stop and look at the lines of code, right?
Oh, true, it's recorded. Cute.
Right, so I tend not to do that. I do it after. All right, so help me, I'm bad with names.
M Delga 49. M Delga 49.
All right, so the grading's insanely crazy on my side, but this is the equivalent that you get. First thing I do is I just sit there and fire off debug. I don't call clean or anything, I just fire off debug and I compile it. And I just make sure it compiles. It compiles, so it compiles and then I run and right now, as it stands, did you check this stuff in for real? Oh shit, it's this thing, sorry.
Oh.
You just scared the living shit out of me.
No.
Thank you for stopping my heart. I appreciate it.
It's no problem, I'm good at that.
But we have
Did
to
you do this?
But you have to do it with a new project because it's
Yeah, I
every
have to go
project.
fuck myself.
No, it's,
we did.
I totally forgot with,
Yeah, but you downloaded another student's project.
Well, it
so
compiles.
it's
Oh,
like
yeah.
settings.
yeah, it compiled fine. All right, we're good again.
Well, yeah, blank files often compile.
All right.
There you go.
Oh, thank fucking Christ.
Keeps it interesting, right? All right, so boom, 18 points, right? So I got 18, so let's go here. Yeah, 18, right? Now, I'll run and release.
Is it okay that the speed on that does not match the speed on mine?
Oh, and yeah, right now you're on a teaching computer, so it's all different.
Okay,
Don't worry about it. I'm just demonstrating how I grade. So I compile it. Cool, compile, I run it. And 18 passed. So this is debug. And release. right? I would take the lower one. I don't care which one's lower. So if you happen not to compile for some reason in release or debug, then your score would be 0 and I take the lower one. So you make sure it compiles and runs them both. All right, so now I would run this thing a billion times, like 6 times, and I record the lowest time. And so the time is, I'm not looking at the mem time, I'm looking at the custom time. I don't even look at the ratio, I just look at the custom time. The reason for that is if memory system was slower, it's going to give you a higher delta. But if I just go away to custom time, this is how many cycles. This is a good time, 284. But I would run it a couple times. And when I'm running it is I'm not actually even running it. So there's 314.
You said you take the lowest?
Yeah, I take the lowest. See, this one's 500. So that's why I run it a couple times because it varies. And so 318.
Right.
And then I have a little score chart here, and it tells you, your times. If your times between this, so you got 4 points, 3 points, 2 points, 1 point, right? So let's just pretend it's 4 points. It's full score there. So now we do the coalescing test. And coalescing test is then done in debug. Okay, and then I get rid of it seemed like a simple move there. Something go wrong. It's the tool that's hanging right now. Nothing you did. Come on. Oh my gosh. All right. That debug one. All right, and then okay, all right, so now let me zoom in here. All right, so now I'm going to do a search here for the word all open files. Oh, wait a minute. Yeah, go here. I go to test 16. Here we go. Put a breakpoint on this section right here. Right. And then I run it. All right, just to make sure it runs completely. So let's see that one test pass. So I'm running again. So I'm at this first point here. If from this line of code here, I'm going to go through, it's going to call all your free code. If I see the word do for a while, and it hits a breakpoint, then you lose a point. If I see nothing, I make it to this next line. you're good. Yes,
Is it? I mean, it's okay when we do add to free list, that has to be a while loop because we iterate through the list.
there's nothing, there should be no word free, do, or that, because you have adjacency information. Right, so anyway, let me continue on and show you. All right, so now, so now what I do is, let me zoom this in so we don't show off all your code. So here's this, and I go current open documents. Look for the word loop, I'm sorry, while. So there's while. Go back through, here's while, so put a breakpoint on this line. Boom. So there's a breakpoint there. There's a while, put a breakpoint there. Boom. There's a while. And then breakpoint here. So yeah, here's a while point. While. So anywhere there's the word while. I'm,
No, I
this is
understand.
programmatic. So and then I do.
You're gonna find a lot of that.
No, actually not. All right, and then for. So now I go back to the test. All right, ready? Now, if I just run and it doesn't hit the do loop, for loop, or while loop, and it makes it to this next location, that means there's no, you get one coalescing point for that. Then the next one is one coalescing, the next one, one coalescing. And so one of this is below, one's above, one's below and below and above, so it's all three conditions, right? So here we go. Boom, 1 point. Boom. Nope.
Any way to avoid that?
Yeah, how are you
Yes.
supposed to add it when you?
Yeah,
don't
like
know
if
what-
I'm
No,
you
you
have
don't, you have all your information.
There is a case, but there's 4 cases, but there's 3 of them in these tests. These are
Right.
the 3 that shouldn't have while.
So right now you, I already lost count. I think you'll have
2 out of 3.
2 out of 3, it looks
You
like.
Go through the,
Oh,
right.
and figure out what's bigger and what's.
Right, so you get 2 out of 3.
Right, you have to
Right.
sort it.
Remember, you still got time to fix this, but you get 3 points for coalescing. So here's your score.
Yeah.
On top.
Oh, I'm sorry, 2 points,
Turn that to free,
right? So this is 624
basically.
minus 5 is
So it should be the
19
same.
out of 20,
You already know where it is.
Yeah, you already know.
That's fine.
right? So, all right, just remind you, you do not need to go through a while loop in case 1, 2, or 3. The reason for that is you have on your linked list,
Oh,
you gotta think all back from linked list, right? So I'm gonna do the cases right here.
it's because when you coalesce below, you can just take its pointers.
I don't know why I'm doing colors that way. It's really gonna, it's gonna be here.
Finding the pointer, right? You gotta.
Well,
So here's,
it's like, if this is already free and I free the one above it, right, I just need to take its place on the free list.
right, so here's
So
the
I can
first
make
scenario.
my
The
Previous.
first
its
scenario
previous,
is
its next,
there's a
its next.
free below it, right?
Right,
And you're gonna
Yeah.
free this guy,
You only change free next into mallet,
right?
Yeah.
And upstream,
next free.
and there's, one downstream, right? So there's some used blocks between here, right? So here's a C, call it C, right? C links to the next free. We'll call this D. And the previous one is B. So here's B and D, right? You're gonna free, this is case 1. You're gonna free this guy up, so these 2 become free. Oops. So these 2 are gonna get freed, right? This is one below. Right? So what you do here is you keep, here's C, you can take the one in front of it, call it R, the one after it, call S. take C off the list. You glue it together and it becomes this new guy. X. And now you're gonna add X between R and S. So there's no need to search the list. Because the whole thing backs off of this observation. This whole thing backs off this observation. I'm gluing to a guy below me. C's on the list and C's on the list in the correct order.
Right.
We're gonna exploit the crap out of that. So we know that in case one, we're going down. So C is interesting to us. So we quickly go to C and we go, okay, the one before C is R, the one after C is S, right?
Right.
And so no matter what we do, we know we take off C and our answer goes between R and S. So there's no searching. There could be 1 million nodes in front of us. Could be 1 million nodes after this. And we don't care because we just know we're putting between R and S.
Right.
And that's why there's no searching.
Do the tests care if you, for case 3?
Okay, wait, so let me get,
Yeah,
so another scenario is this one where you're gonna free this guy, right? So this one above it, right? Let's call this A, B, and C.
is that the one you were looping or was it the other one?
I did a loop for when,
I have no idea which one it was.
it was I remember, it's the one where I free something and the one below it is already free.
Okay, so here.
Okay.
Here's this one right here. And what we're gonna be doing is we're gonna free the one above us, right? What's of concern to us is B. Right, so we go to B. We go to the one in front of us, call that R. Go to the one after us, call that S. And we take B off of it. And then when we glue this together, we put the glue between those two. Again, not searching. And then when we do the one above and below, we have great. And this is A, B, C, E. Right, or these are all linked together. And we're freeing up this one right here, which is the middle. So now we're in the middle where we're actually worried about B and C. So here's B and here's C. Take the one in front, call this R. Sorry, B and C. And then take the one after C, call this S. Right, then take out everything between there. And now create the super glued one. And place it between R and S. No looping again. And this is why, to me, you know, I made up this algorithm, you know, this gluing and all stuff. This is my own dream. But I think it's so much easier when I just discriminate and saying, hey, it's case 0, case 1, case 2, case 3. And it just tells me how to find R and S. Now, if I'm in case 0, that means the guy above me is used and the guy below me is used, I have to do a loop, because I have to find out where to go. If your while loop, do loop, or for loop just instantly answer and doesn't check it, I can't programmatically check it. If I see the word for loop, do, or while, I put a breakpoint. If it hits the breakpoint, tough rocks. So just make sure you're not doing it only for case 0.
Do the tests care whether the pointer that you end up with in the free list are the pointer from B or the pointer from C? It doesn't really matter programmatically, but I was wondering if, I'm not there yet. I'm wondering if the tests care.
The test is going to check the end result. It doesn't know.
The address?
Yeah.
Well, I mean, because there'll be in a,
All I'm going to test is A, the X, and D.
uh,
I don't know that how you got there.
so for the placement, the address has to be the address of B,
Right.
but
Absolutely.
for the link position.
It has to be still linking to that
There-
address, that physical address. And this is why it's smarter just to take it completely off and this add between R and S. Because sometimes the R, the next of R is the same or it changes. Sometimes the previous of S is the same as before or it changes. So I'm like, again, programmatically, I just say, I do the same thing every time. I always just take it off. Here's R and S, add it between the two. Then I don't have to worry about the pointers.
So do you use RNS for the case 1 and case 2?
Yeah,
Okay,
yeah, you just saw that here. Here's case 1,
yeah, okay.
Oh, so you just, oh, okay, I see.
case 1. Right, here's case 2. Right, then here's case 3. And in case 0, I have nobody who's neighboring me who's free, so I have to search the list for the insert. Does that make sense?
Yeah.
All right, so there was one question during office hours, which was a very good question. The question was, do I need to change my next fit on Malik's? Yes, every single time. When you call Malik, your next fit changes. On free, sometimes, right? So I'm gonna give you that sometimes scenario. Your next fit right here points to this guy here, A, right? And we're gonna free B. We're free B. So now your new diagram looks like this. B. And your next fit, if you don't change it, it points into the center of it. Because I glued up. And so it really should now point to that location. So does that make sense? Is this a weird edge condition? Sorry. So you just would glue up.
Great. And, oh, wait, yeah, that's easy to check too.
Yeah, well, it just, to me, if you always go with the rule, or keep it stupid, you know, KISS, keep it simple, stupid. If you go with the rule of this, I always, when I add a new free list, I always update the next pointer, the sacred pointer, and the neighbor below you. If you just always do that, you don't get in trouble. Get clever, then you get bit by an edge condition. I thought of an evil scenario that I think I'll add a unit test, but not this quarter. But the evil one I just realized I'm not doing is the guy below you is free. The guy above you is free. The block you're going to remove is this one, and it's at the bottom of the heap. Well, that's a real condition because you can't get You can get R, but you can't get S. Because
Because S would be nothing.
S is out here, this is nothing.
Oh, you just have to,
It'd be no point.
That makes it an edge condition.
yes, you just have.
And
to-
the same thing's true for the first, if I put the 3 on the top at the first.
Yeah, I have.
So, mental note, I'm gonna leave my note to myself, add to equal test. All right, so there's my note. So I'm gonna add those scenarios. We're not testing that. But that is an interesting evil scenario.
Can you say again why that's hard, right? Because I can get the
We
bottom.
Okay, so right here, let's look at this, case 3. Case 3, you have to find R and S, which is A and D. Right? But if your heap bottom happens to be right there, you can't get D. So now you're just on edge condition,
But you know where C is.
right? But you have to be aware of,
Oh, yeah, yeah. You have to.
and it's likewise the same is true as if it's at the top. The same thing.
No,
it's just the edge of
Right, so the
heap.
linked list doesn't wrap, it's the tail.
Right,
Yeah, you just gotta know if you're at the tail.
so it just,
I just have to handle a tail.
yeah, but
Okay.
it just adds another condition. All right,
Which is point to null point.
but it would make it would add 2 more unit tests, will make it a little more.
Is it that hard to handle this kind of
No,
edge condition?
No, it's.
No.
It
it's
sounds
two-
that
it's-
difficult.
it's One line of code
Yeah,
saying
it's
check if null and,
Yeah,
if C is null, you can't go to S.
So, no.
But then you have to be aware of that you're adding it to the
Yeah.
end of this. It's really simple, but it's an edge condition I didn't test, so I'm
so you don't have
bad,
to worry about
So-
that.
yeah.
What I was trying to say on some of the Piazza conversation is, hey, wouldn't it be cool if, because you've got like boundary checking memory allocated down there anyway. If you actually put a pointer down there, put a header down there at the top and the bottom of your thing.
I'm not, you can say that 10 more times, you said it the first time we talked about memory system. No, we're hardcore programmers, we don't put boundaries.
But it saves you, it's performance motivation to do it, because it saves you a check for the boundary.
We have to count for every byte, that's just wasted overhead.
Hmm.
We're hardcore people, we don't do that. That's totally a DS system 1 kind of move, right?
We know the size of everything. We
We're
know where
better than that.
everything is.
What?
We already know where everything is. We don't need extras.
Yeah, so we put on,
Saves a check
no,
at every step.
we drive with no synchro mesh, stick shift only. Right, we're getting the most out of our car. All right, other questions? Like 3 people smiled, they probably know what I just said.
Stick shift, so that makes it even better.
All right, anything else on PA4? All right, and the basics for, I forgot the hell what it was. Strings, yes.
Real quick I realized I had some trouble with free head. I just want to know what scenario should we be updating free head? Like specifically with coalescing, because I know gives you.
It's, think of the free head, if you think about your diagram for your heap, so here's your heap, right? And the heap always gonna point to the first, so this is the free head, right? If you change this guy, that's when you update it.
All right, so it's whenever you change,
Yeah.
So free head is involved in any, coalesce,
Mhm.
change it.
Yeah, and how you know you're changing this, if you're changing the one with the null,
Oh, okay.
That's a
So
previous
Previous
thing.
is null then.
yeah.
Okay.
Same as the
So,
first order of the hot
um,
dog stand.
It, to me, it seems pretty easy when I never thought of that condition, to be very honest. The reason why I don't is because I'm doing things the stupid, simple way. And my way is, if my first block, I take it off the list. I have a function that says remove, and that automatically updates my free header.
Oh,
So then I'm like, okay, there it goes. So my remove a node, this always takes account of that. So I don't really never think about that.
okay.
So remember your remove function, you really have 4 conditions. Removing something in a linked list in the middle, something at the end, something at the first, and something that is the only. And those 4 conditions cover any way you can remove a linked list, and you would have that same problem for used as well. All right, plug with it, you guys will get there. I'm very comfortable that you guys will, the questions are good. Yeah, I feel like you understand the material. Now it's just like a little sweat equity, right? Go through the unit tests for the people who finish this. It's just straight down the line, right? You just keep going through one test, the next test, the next test, and you'll get there. Each test checks another boundary. Once in a while, you might get through 4 tests and they're hard. Then all of a sudden, like 7, 8, 9 come like free, or like you get a couple of just like, whoa, that's nice. I just got 3 tests working and you didn't do anything just because your logic's good. And then all of a sudden like, and it's probably the boundary. All right, other questions on P4 memory system? Wrath of Khan. All right, strings. Questions on the strings basics? All right. So strings basic, the problem area, in my opinion, that's giving everybody trouble is using quicksort. It's a really weird esoteric function. Google, search through it, post questions on Piazza. It's really an archaic function, but it's used. And the second thing is the tokenizer. String token _s. And basically what you have to do is put in what you're searching for. You're searching for a space. And then you have to have a context, which just says, the last time I look at it here, the thing that's not obvious with the tokenizer, it actually is destructive. Right? So let's say this is our string, right? And so what we'll have here is space, terminator, right? So this is our string. When you use the tokenizer, it's going to say, okay, here's well, I don't know what just happened. All right, I don't think that's working. Let's do it this way. So you do your tokenizer, it points to this, and you're saying search your token is space. So it finds token like, I found it here. Here's my token. It's going to jam now a 0 there and return P. So now your first word is ABC terminator. Then you pass in your context and it stores off like, where was your last at? Okay, got you. And so it continues. It goes, and it starts now here and it goes, looks found space. So then it's going to jam in a 0 here and give you this one. Then it takes the context, says, okay, we'll continue on, start here, found it, here's your P. So if you look at this line versus this line, this is destructive. It changed data. So generally, the first thing you do when you're using the tokenizer is you say, what's the length of my string? Create a new memories, copy it. And now you play with your copy. So the tokenizer is a little bit weird and wanky. It's destructive. And then the quick sort, you have to add a function to compare. That was the hardest one there. The rest of those are pretty simple. All right. Let's start new material. All right, so here's PA1. So here's PAs. 1, 2, 3, 4. All right. PA1, 0 to 10, how hard was PA1? When you were doing it?
Like a 6.
Six.
Okay,
Not
6.
bad, yeah.
I am losing.
All right.
track.
PA2, hot cold, Jedi, how hard?
I 7, 8. something like that.
6,
8 to
yeah.
9.
All right,
Plus.
all right, is it pre or post?
Are we evaluating an expression or
I'm just telling you. is
Modifying
it
the
pre or
value.
post?
Yeah.
Do you return immediately, and then increment, or do you pre-increment,
Great.
right? So it's plus, right? As a pre, all right. PA 3, which is first 5 unit tests,
5, 8, 4. It's not hard.
right? And then PA 4,
10.
Eight.
10.
right? So you can see here, I kind of do this, right? So if I'm a nice guy, this should be down here.
Not gonna happen.
But
No, it will be.
the word,
Oh,
Oh, yeah, I use
Oh,
it to
don't
do
get my
games.
hopes up.
I use it to do games, so I like build you up, get you, stressed, and then I give you a relaxer, and then I stress you again, relaxer, and then fine.
there's a lot of evil that's been thrown around and stuff, so I don't know.
Yeah. Oh, you'll see later, there's, I'm not linear. All right. So PA 5 is kind of the recovery PA to kind of make you feel good again, a little lighter and easier. So PA 5 is a lot of interesting problems that are, let's make sure this right. Good. PA 5 is, what's interesting is it's there's like 4 different concepts we're gonna go through PA 5, and even one's really not that big, so it becomes like a collection of 4 of them. And so they're all pretty simple, right? So the first one is implicit operations, right? So we're gonna understand implicit things, kind of understand switches and a couple of things, compiler settings, right? All right, so if you convert it into a float, right? Really simple. You have int x equals, some value. And maybe your value is a float. Value 5.0 f. Will this compile?
No.
We have 1 no.
I'll say yes, just to be contrarian.
Yes, this will compile.
Okay, then yeah, that's contrarian.
It will yell at you and saying there's a warning. You're trying to take a float into an integer, right? And we could do the reverse. We can have an integer getting passed to a float. Oh, I'm sorry, integer to float. So let me just change this words. Right? Will this compile? Yes, it will compile, but it will give you a warning, right? And on the Intel compiler or AMD processor, this is about 1 or 2 cycles. Just over there, it happens so frequently, right? But then you hop into Xbox 360, which is basically an Intel is an out of order execution pipeline. But when you get into bigger processors that do more, it's in order, right? And the problem is the cost is very, very big. So normally it's like 1 to 4 cycles, but now suddenly it jumps up to 40 cycles or 80 cycles, right? And so how it works is this. Here's your CPU. And here's instructions. All right, so these instructions get fed to the CPU. And then all of a sudden it goes. This one says convert a int to a float. The compiler sees this and goes, holy crap, why in the hell would you do that? It goes, all right, we'll do it. And it writes it to memory. So it writes the number 5 to memory. Because it was an integer 5, and it's going to become 5.0f. Then it reads it back from memory. When it reads back from memory, it converts it to a float. Now it's 5.0f. All of these cycles get aborted. Boom, they throw them away. Because you have to wait until you write, delay, read, convert on read, more delay. Now, thank you very much. You can go into the processor. That delay is horrible. Turns out on the Intel and AMD things, it's 1 or 2 cycles. It's, you know, it's really lightweight. But when you get to more advanced processors, this will just bring you to your knees and slow it down. And the reason is we're doing this conversion. This conversion costs money because we're converting this and we're changing the bit pattern, right? So we're going from a 2's complement to an IEEE 754 format. So how do we prevent it from happening? We don't want this. And the thing here is, you guys are the software engineers, you're the architects, and you're the heavy hitters, right? You're the experts at a company. How do you prevent somebody using your code and slowing it down? And you know what they're gonna blame? It's not them. They're gonna blame you, because they're like, your code's slow, and you have some really cool function here, and it takes in a float, and you know, some goofy guy will just go, okay, I'll pass in an int, you know, int I, they pass an I to the function, and it slows down. Or the function's in a loop, so it's been called 1,000 times, it's passing an integer, passing an integer, passing an integer 1,000 times. Now the thing just crawls. How do we prevent that?
Is there something you can do to make it so you can't take like anything, like you can't even take a converted version of that thing?
You tell me. You just said my question.
Oh, yeah.
So one of the things we can do, turn up the compiler warnings, right? In this class here, I put it on crazy mode, right? So it's warning all, right? But guess what happens? In industry, a lot of people are like, oh, there's too many warnings, and they turn off the warnings. I'm not kidding you. That's really, and they say it in that high pitched voice too. So they turn off the warnings, right? So we can say treat warnings as errors. I also do this because it's an option. Again, they can turn that off as well. It's like, well, hell, if I don't like warnings, I really don't want warnings as errors. So that's even more crazy sauce. So what if you can make it as an automatic compiler error? So if you can make this a compiler error, that would be great, because then they would have to address this. So if you sat there and had a foo, and someone passed an I, an integer into it, into I equals 5, and this gives you a compiler error, now we're stopping the train, and somebody has to fix it. Now the programmer guy, you know, he or she can say, you know what, there's an error, I can fix that. And so all they do is they go, fine, float I, there, shut up compiler, right? And that's legal. But now if it slows down, you can say, you see that little cast you did right here? That's why it's slow. Not my function's fast, but you broke the rules and you gave me an integer and you cast it. That cast is the slow part, not my code. So we want to move the problem onto the other person. Our code is great, right? So how do we prevent it? Well, how do you prevent a constructor from being called?
delete it. Just-
We can say equal delete.
Yeah, just delete it.
Let's say you don't use equal delete. What's another way to prevent it from being called?
Equals default,
No,
prevent it from being called, oh,
Make it private.
make it private. Exactly. We can just move it private. So what we can take is take that function, let's move it private. Now, if somebody tries to call it like illegal access to a private. So that's cool, right? So now, how do we deal with this? We have float set x, right? And if we want to prevent this from being called, I'm sorry, this is what we want, it's public. We want you to pass a float.
Yeah.
We don't want the integer. What do?
create a private.
We overload it. And we say, here's one that has an integer. And it becomes private. So now, whenever they pass an integer, they're like, perfect match. And warning error, or error actually, because it's accessing a private method. So we just gave them the finger, right? So that's cool. But here's where it gets more interesting. What happens if we pass in a character?
That's only one byte in the float.
Is it for a float or for a?
Passing a character into a float.
It would just do it, right? Because it's, do you have to convert it? Because it's just,
What about a double to a float?
how much is a float?
They're all the same, right?
How many bytes is
I
a
mean,
float?
truncation.
The same.
What if you had an apple and it gets converted to a float? Right? So now you can't write private apple,
Oh, yeah.
Yeah,
private double, private character. Because no matter how many you write in there, I'll come up with one new one that will break your house of cards, right? So how do we deal with this when we want to deal with many? Right? We want to deal with anything here.
is there like some, is object, can you just like accept any object?
Yeah, so how would you do that? Accept any object.
Void?
Yeah.
It's not void, is it?
So we're gonna use templates.
Okay, of course.
So now everything matches private. The whole world matches private. Ostrich. Fine, if you pass in ostrich to a set X, bingo, it makes it. But it's private. So it's gonna give you compiler error.
Alright,
But then you pass in a float. Now we get into compiler rules. Compiler goes, here's a generic template that takes anything, and here's a car that only fits a float. So it says, I will take the most restrictive choice. And the most restrictive choice is a float. So in this case, if you pass a float, it won't match the template because a perfect match is in the public.
right.
So it goes to the public. And so by doing this trick, we essentially just made a compiler error that is programmer independent. So if they change the settings, we don't care, because this is a language construct. Private's private, right? So this is how we prevent conversions from happening, right? This little trick will future-proof your code, because when you write C++ code, people can take the file, the function, kind of paste stuff out and move it to another compiler, onto a server, onto different solutions. We don't have control of how those settings are set, but because it's in private space, it will still yell at the person and stop them from doing the conversion. If they decide to do that casting trick, hey, you did it, not me. My code's fast. You're the one who slowed it down, right? And that's implicit. So not much there to do. Switch statements, it's a little, you have like loose change here. Switch statements, what you want to do is, a switch statement is really an if, else if, else if, else if, else if, right? For those who work in industry, this will make a lot of sense. If you're in somebody else's code and you need to add a new switch case, where do you put your code? Case,
At the top.
you put it at the top.
The bottom. 'cause
You're the first person in my 20-some years who does it on the top. Everybody else I know, except Paul, puts it at the bottom of the switch statement. The problem here is when you're dealing with large switch statements, you'll see this for like Windows messaging, like what keyboard was pressed, what action should I do? It's literally, I've seen ones that are 3,000 switches. So now it goes, if escape button press, nope. Else if backspace press, nope. Else if comma press, nope. And it keeps going until it hits your key. And if you add your stuff to the list, you just went through a couple, 1,000 conditionals, right? So then, Paul's solution might be better. Just jam it to the front.
Make sure my code runs.
Right. The reality is the best way to do this is to take every case and put a counter. Run your application, 30, 40 times and see which numbers tend to be hit more frequently. Those should be at the top of the switch statements, and what's less should be at the bottom. If you do your switch statements using enumerations, if you go enum, type, and you have, red, yellow, and you set the first one to 0, or you don't set it at all because it defaults to 0. All these numbers will be next to each other. The compiler sometimes can say, you know what, I can do a jump table. It says, hey, your enumeration is 13. I'll just jump down to the 13th case and skip the switch statements. So sometimes the compiler is smart enough to do that. But if you define them as integers, if you sit there and have numbers all not next to each other, you don't get that benefit, right? So enumerations help you. Switch statements can be costly. Big switch statements suck, right? In CSC461, I found a way to do switch statements where it's only 2 conditionals. Whether you have 3,000 or 2 or 20, you don't have to go through the switch statements. So in OO classes, we'll kind of talk about a different technique on that using the visitor pattern. All right, yeah, no, this is it. All right. Variable usage. Keep your variables counts small. If your function has 3 variables, chances are all that stuff can kind of get optimized very well. If your function has 30 variables, it tends to start using the stack and starts becoming more and more inefficient. Declare your variables in the innermost scope. If you have a function and you go int x, right? Or not even do int, let's do a class. Dog d, right? And then in here is if some statement, and this is where you're going to use d dot x equals 5, right? This is the only time and place you're using it. Do not declare dog in above the condition. Try to declare your variables as lazy and as late as possible. So if we move this dog declaration from there, and we just define it here, sometimes this condition doesn't happen, so then you don't define dog. So you skip it. So you try to define your variables in the innermost loop, and you try to be as lazy as possible. And this way, on frequency, sometimes you don't even instantiate it at all, and it goes faster. That does not want to delete. Right.
So if it's inside of a loop and you have the declaration, is it just, it gets skipped on automatically on subsequent iterations?
The compiler should do that. Now in loops, I will declare it because the loop I know it's going to fall through. I will declare the instantiation outside the loop once. So then the compiler, remember, the deal with the compiler is we don't get control. It has its own mind. We try to create an environment that we're nudging it to do good things. We're hoping even when we're dumb, it's smart. So in a for loop, if you know it's going to go through for loop and go through all the things in your container or your list, and you're reasonably certain like it's going to go through this, I have some work to do, I would declare my variable just in front of the for loop. So then there's no way the compiler can misconstrue to keep creating it, 500 times. You know what I mean? So you just have to kind of stop and think about what way could the compiler, if you define it inside it, that you're hoping that the compiler goes, it's the same variable being initialized, 500 times, we only need to initialize it once. The compiler's pretty smart, it probably will do that. I don't want to trust that. I want to kind of create an environment that it can't screw it up. All right, compiler settings, right? There's this trade-off of performance versus size. So if you want code to run faster, it generally is a larger exe and uses more data. If you want code to be really small footprint, it tends to be more inefficient. It takes more cycles to kind of compact and deal with things. Debugging versus speed. If you want code that has debugging information, it will go slower. If it's wants stuff to run faster, it doesn't have debugging information, right? How much time does it take to compile? If you want things to optimize and shrink and inline, it's going to take more cycles than something that is slower. That's a little simpler. So think about in your memory system, when you compile it for debug, it goes, it's done. It's doing release, it cooks for a while before it's done. That's the duration time, right? So you can spend forever on this. And you can get a lot of speed improvements because you know your environment. The compiler does its settings and says, we have sampled so many programmers and this seems to be the most average scenario that we want. Here's our choices. But because you are you know the environment, you know the who's using it, how it's being used, you can set those settings. So give me an instance, RTTI, right? It's real-time type information. And this tells you how a class is inherited and what properties it has. So if you have a class here, A inherits B, and you have a P, A pointer, can I cast it to a B object? That's a downcast. Generally is illegal. But if you have RTTI, it's like going, well, actually, it was born a B object. It's polymorphically set as an A pointer. You can still move it back to a B. It's okay because it was born that way. Well, you need tracking information and traits and all this other information. So you have RTTI turned on. If you turn RTTI on it, 20% slower, your whole program. Even if you don't use it, all your code has RTTI flags on there and it goes slower. If you need RTTI, you screwed up. You should be using C# or Java anyway. This is just one setting. So if you turn it on, boom, 20% slower. So different compilers run differently. Microsoft versus Intel versus GCC, Metroworks, all these ones have, sometimes they're better and some ones are worse. But there's really interesting things. Intel compiler tends to run really good on Intel processors. Maybe they have some inside knowledge, right? I talked with the Intel guys and they're like, they don't sell much of their compilers. The compiler is you just plug it into Microsoft and it works. So the editor, you just like install Intel and it's like, you just click it and it just runs. It runs significantly faster. And so I was talking to Intel and they're like, oh, we want to give it free because we're really proud of our compiler. It kicks ass and takes names, but management doesn't want to give it up. And so they charge $800 for the compiler, just the compiler. And so what we do is when you're in industry and let's say you're making an application that's going on PCs, everybody develops in Microsoft, and then you have one machine that you bought the Intel license and you go, thank you, compile, okay, ship that one. And now it's faster, right? So the cheapest way to speed up your code is to change your settings, right? So I had this young developer working for me and he was doing stripping. And stripping isn't as cool and as graphic as you think. It's making triangles strips. So you're taking a lot of points and you're making a strip of triangles. And our deal was always in our company or in my group is we would sit there and say, if I can break your code, you owe me a beverage, like a pop or a soda fountain drink from 7-Eleven now. Like get in your car, drive and get me one and bring it back. That's your penalty. So if I can break your code, I get an instant beverage. And so we make also bets for lunch. So he's working on this, he's using STL. And he's like going, it's taking me, 45 minutes to stripify this model. And I'm like, oh, cool. And I'm like, what container are you using? It's like, I'm using STL list. I'm like, try vector. Works on it for a couple more hours. It goes back like, oh my God, it's so much better. From 45 minutes, it's down to 5 minutes. Like huge improvement. I'm like, yeah, I told you, you're using the right container, right? So I'm like, hey, we're ready, time to go lunch. And I look, and I go, what time are you getting? He's like, around 5 minutes. I'm looking over his shoulder and I said, I can make your thing go twice as fast. He's like, no, you can't. I said, I can do it in a minute, but you have to leave the room. The deal is if it goes faster, lunch. He goes, deal. Leaves the room, kick him out. I go to his machine, I switch it from debug to release. Right? The point is, the release has all the settings to make the code run faster. He's running everything in debug, which adds tracking information, debug information, printing information. And it ran from 5 minutes down to 35 seconds. So I got my free lunch and he had to learn the hard way. All right. So here's our compiling settings. So there's a website here and it's tons of settings. You kind of go in here and you just go into like, boom, like category. Here's, OG. This is what the OG setting does, right? So there's a lot of settings, right? So, here's just some of them. And if you turn one flag on, it might stop another flag, right? So the homework assignment is that you're going to be given code, and I'm going to give you the code and here it is in debug. Dunk, we get our times. Here it is in release. Boom, here's the times. Then I'm going to copy release and say, here it is. You change the settings, see if you can beat it. And I call that one Mr. Fast. So that is really was standing for midway runtime fast. But I just like the word Mr. It sounds like it's more intelligent. So you're going to take so I copy all the release settings. So it's exactly the same as release. Then you're going to start switching the knobs and make it faster. And that's the assignment. It says, how much faster can you do it? So it's not hard, but you noodle with the things, and whatever flags you change, you just record.
So just a bunch of fine tuning and just finicky.
Just fine tuning. And this shows you the simplest thing to speed up your code is, are you on a good compiler and do you set the settings? You didn't do any coding. You're just like, change the knobs, right? And I'm sure somebody who's good at AI can make this really cook overnight and just have the AI adjust it. Right.
So the link to the compiler setting doc is all in the
Yeah.
in the
And you can Google it as well.
I mean, it's
All right, so let's do one more and then we do break. This one is. All right, return value optimization. So return value optimization is a really critical kind of technique. Once you see it, you do it forever. This technique obviously also works on Java and C#. This is not unique to C++, right? And this is also good material at weddings and funerals, right? I'm Irish, so we used to go to funerals and that was like the fun time. Like mom can't yell at you. You can drink and steal a cigarette when you're 8 years old and she doesn't want to make a scene. And, Uncle Jack is ripped, with a bottle there. Then we pour some on the dead body because he's thirsty, the whole deal. So funerals are good in my culture. It's sad in some other people's, but you want to go to Irish funeral. All right. Or Irish wake. All right. What's going on? What's the difference between these three pieces of code? We're going to start with number 4. What does number 4 do?
It's an assignment operator, right? What assigns T to you?
It just allocates memory on the stack.
Oh, yeah.
So allocates memory in stack.
Oh, I
Size
T just time on one.
What?
No, it just says, hey, I'm gonna use a T at some point.
Yeah.
So this is a default constructor. Right, on the stack. Number 3,
It's also a default constructor.
on the heap.
it's a prototype, it doesn't call anything, it's a function signature.
Oh,
So when you do default, you don't put parentheses, when you declare it, we put parentheses when you declare the prototype or the interface. Right? What is U? I mean, what is number 2?
It's the same.
So it's a constructor that takes in type U, right? So it's a specialized constructor. What is number 1?
That's the
Hmm?
assignment. The assignment operator, right?
You would think that, but you're wrong.
Okay. Nice.
That's just the copy operator then? No, because copy is,
Initializing T.
This is the copy constructor,
it is the copy, that's, yeah, okay.
right? It looks like it's an assignment operator, but it's on construction, so it actually lays onto a copy constructor.
Which I thought.
So if I ask you these 3 questions or four questions, these are pretty low bar questions, right? But see how complicated they can get? So there's this website called Guru of the Week. And this website here, if you go all the way down to the first one, variable initialization, here's the 4. And then this description of all of them, right? And then here's the second one, temporary objects. And it just keeps going and building. And so these are things that kind of get you thinking about, do you understand the language enough? The first 30 of these, he put into a book called Exceptional C++. So then each of these things are chapters, and he talks about it for pages, and you learn a lot more. Then he prototyped the next so many, and he called that a book. The next so many, and called that a book, right? So this is Guru of the Week. And it's written by Herb Sutter. Herb Sutter, he's worked with Dr. Dobbs, C++ journal. He's now the head of the Microsoft compiler team. Probably one of the smartest people I met. Seriously. If you get to see, if you're taking more classes with me, you'll see him in lectures. You know, we have some video lectures that people watch. And he's the one who started to fix a lot of the problems with language. He's also on the language committee, right? So here's some of the books he's written. And anything you get from Sutter is gold. It's pure gold, right? So when you see this stuff, what you want to do is these books remind you how complicated language is and how difficult it is. And it really takes a long time to master it. So, let's see. Yeah, so I think it might be a slide later, but I'll mention this now. So Herb Sutter is the head of the compiler standards committee and also head of Microsoft compiler team. There's another guy named Scott Myers. He writes critical books, the Effective C++ series. And then there's Strausstrup, who wrote the language. So you ask the guy, you take him aside, like, hey, how many points do you give yourself out of 10 on knowing C++? So the person who wrote the language says, about a 5.5 to 6 out of 10. It's that complicated. I don't even know my own stuff.
Mhm.
Then you talk to Sutter, who's seen every compiler bug known to man, and who's dealing with expert teams who are breaking things. And he's like, I'm a solid 7. Right? And you see, and he writes books. And the other guy, Myers, he writes critical books and teaches you issues for a living. And he's like, I'm a 7. Right? So if they ask you, what is your ability at C++, you look them square in the eye and say, I'm a solid 2. Right? And here's why. And then we tells you 9 or 10, you shoot them on sight because they must be a witch. But they're totally lying, because if the guy who invented the language, the guy who cleans up the language, the guy who writes the language, give themselves 6 and 7s, a 2 or a 3 is not bad. Right? So it kind of shows you kind of the perspective that this stuff is much more complicated than it appears. All right, to understand implicit behavior of this stuff, understand what code is really happening, is you look at the sandbox, the original sandbox I gave you, I printed out all the overloaded functions. You can see what's being called. So you make a test bed, overload everything, and prints everywhere, right? So here's some code that does that. So here's code that's listed everywhere. And what we have here is the constructors, a specialized overloaded function, right? This is a copy constructor, and then we have a Boolean operator add, and we have assignment and a destructor, right? So very simple code. So how many constructors and destructors happens with this line of code? So imagine there's, I'm not going to write it here, but imagine there's curly braces on this. So it gets constructed, it gets destroyed. How many constructors and destructors are called for this instruction? The class is literally int x, nothing fancy. You know, so there's this one int at the bottom. This holds that, and that's all it does. So how many constructors and destructors in this? You construct it and then it leaves scope, it destructs. How many are called? Just one. It's constructed and then leaves scope and calls destructor, right? Easy. Now this one. So what is it calling? Copy constructor, right? And so it's calling the copy constructor. Well, I'm sorry, this one's taken a specialized constructor. It's taken an int. It's the copy constructor would have to pass in a type A object.
Right, it's
So
taking.
this is a specialized constructor. Little different syntax there. You know, normally we're used to seeing temp 8, right?
Right.
This is equal, but because it's on the construction line, it evaluates to that guy. So it just has the specialized constructor int and then it leaves itself, right? So here's this.
So constructor.
So the first one's default constructor,
That copy.
then it's a copy constructor,
And then
Nice.
delete.
then it's going to delete in which order?
First and last out.
So it's going to think about the stack,
First.
right?
And
So it's going to now get rid of A next, temp, then it will get rid of B last. Temp and then B.
Oh, because you do. and then
So it
you
goes-
delete it.
B was created, then temp was created, free it up, reversed order,
Temp.
temp, then
Yeah, so it
B,
is first and last out. Okay. That's what I
right?
thought.
So, all right, this one here,
Ooh,
special.
it's the same as number 2.
yeah, it's a special. It's another way to write it. Yeah.
Right, so never assume you understand it, always look at the stuff. So here's my slide. I was like, I know I had the slide somewhere. Sutter and Myers give themselves a 7 out of 10, right? It's that big, right? So now let's look at this chunk of code. There's 3 lines of code, right? And then 1 addition. The question is, how many constructors and destructors are being fired off in this code base right here?
Five constructors and 3 destructors.
Okay, so right off the bat, you should understand whatever you just said was 100% wrong.
Wait, because it's not one of
It has
these.
to be
Yeah,
symmetrical.
It has to be
Symmetrical,
symmetrical.
yeah, yeah. Cool, because you're.
It's kind of like somebody goes like this, eigenvalues, like going, how many complex conjugates? I'm like going, it has to be at least, for every complex number, it has to be a complex conjugate, it has to be in pairs.
It'd be 4 then, 4 and 4.
So you're saying 4 constructors, 4 destructors?
Yes.
3, right? Let's take a look. Oh, I'm sorry. Let's do this again. I forgot the bit of code there because we can't remember how the plus operator works. I just cut and paste it here.
Right,
Okay, so how many total constructors and total destructors?
all right, so 5 and 5 now. they send that new information.
5 and 5.
Wait, oh no, that's,
Now it's 4 and 4.
you know, just 1 4.
Just imagine there's curly braces around this whole thing.
Yeah, I was just looking at the
So you got 4 and 4?
uh,
Okay. So first one, number 1.
Yeah.
Constructor, specialized, right? It's easy. Number 2,
specialized,
specialize on S.
default,
Number 3, default.
and then it's the overload
Right.
operator.
Then we're going into,
It's the sum.
we're going into the plus operator. So we're going into this guy right here. Right? Then we have the sum. Here's a default constructor. Right? Now, we're gonna add these two together. This is an integer plus integer. We can't do integer equals sum because this side here, this side needs to be a sum. So it becomes an A object that takes an integer.
You're calling it again.
So this is another constructor,
Yeah, it's another one, yeah.
right? It does the assignment. Right? Now, we don't need that temporary anymore. So this is,
7.
so right here, here's T1, right? This is T2, right? Once we do the assignment over, right, we don't need T2 anymore because it was just needed, so got rid of T2. Now we're gonna return sum. We're returning,
A. This goes to K.
we're returning A. We're returning a copy.
Oh my God.
So this is going to get copied. So now this is going to be a copy of an A object. And now that gets assigned
Now it
over,
gets put in, yeah.
right? So the copy here is T3. Once we do T3, now we can get rid of T1 because we're not using it, we're outside the function now. And now we do the assignment, and now we can backwash it off, get rid of T3. Now K, S, and R, right? So 6 and 6.
Is it anything saved if instead of assigning to sum, you just return the,
Well, this is it. That's what we're going to go through is the return to
Okay.
value optimization. But you can see pretty basic code. And now we're at 6 and 6, right? So now, so the temporary is what's going to get you in trouble, right? You know, we added 3 temporaries. Can we write our code to remove those temporaries? So there is 2 techniques here. There's called name return value optimization. And oops. So this is called name return value optimization. We have the name sum is being returned, right? Some compilers can do this, but we shouldn't rely on this. It's not a guarantee, right? So this name, some compilers don't rely on this. But what we want to do is an unnamed one. And what we're going to do is we're going to do an unnamed, but we have one precondition. My new technique works if and only if, right? To use the math terms, I, F, F, if and only if you define the copy constructor.
Right.
If you don't define the copy constructor, my technique doesn't work. If you define it, it works. But you are always going to define the big
Yeah,
4.
why wouldn't you define it?
So then you're always enabling this. But if you don't, and you're lazy, like I'm not going to define the copy constructor, that's a waste of my time. You just lost this optimization.
Right.
So, you know, always do the big 4, just blindly, and you won't go wrong. Right. So here we go. Instead of doing this part here, we have the copy constructor defined. We're gonna do all of our work in the copy constructor. Right. So now let's count our things. We have the first 3, there's the easy. Now we go to the plus operator, right? Now we're gonna overload. We're gonna do this, you know, creates a integer there, right? So that's T1. Oops. T1. Right, now we're gonna do the assignment. And so T1 comes over here. It does assignment to K. Then we can get rid of it. And we're done, right? So now we're at 4. It's quite good.
Yeah,
Can we do better?
I unknowingly did that on hot dog, interesting.
So now if we just move this plus to the assignment,
Oh, yeah.
because why did we do a default where we're gonna trash it the very next line?
Yeah,
Why don't we just move our addition into the construction line? And we call this term a factory construction, it's what they call it. Now, it's literally
3.
3 and 3. Now, here's what's scary. This is 2 times faster than our first pass of code. If we didn't change much, right?
Yeah,
All we just said, oh, we're doing addition or binary, do all the work in the constructor. And if you're gonna turn around and re-sign it, sign it on the construction line.
right.
That's the 2 changes, 2 times faster. And once you do this, you start doing this everywhere and it just becomes a second nature. Right? So, you know the golden hammer scenario, right? I have a golden hammer, so then everything is a nail. You're looking for nails, like I want to use my hammer, and you start pounding on things like, things you shouldn't pound on, right? Because you're like, I want an excuse to use my hammer, right? So let's do this. What is better? A, it's like almost like the eye doctor, A or B?
B.
B, because remember, A is going to create a temp, and then temp gets written over, where B just writes right into it, no temp. Right? So same is true, plus, minus, divide, times, equal.
Yeah.
Right? Now, here's a way that looks weird. A plus B equals C, right? But if you rewrite it this way, that's faster.
Because you're not calling the copy, you're calling,
There's no temp.
there's no temp.
What I would do is I would say faster below and say, this is what I'm trying to do. Here it is, the code underneath. So this way it helps people when they glance at it. But that's faster. Right. All right, so end of this, then we'll do break. Who's that? Sturstrup, right, human in C++.
Yeah. Oh, the guy who wrote the book.
Yeah, this is Sutter,
Yeah.
right?
That's the guy who wrote the other book.
Yeah, this is Myers, the effective C++. So the effective series,
That name sounds.
and it is his hair. Someday he's gonna like
And.
take a swing at me. All right, so these 2 guys.
Ampersand.
So the hint is KNR.
Kernigan and Ritchie.
There you go. The minutes of the C language. Right.
Mm.
All right. Now think about it for a second. Let's say you're a pro golf player, right? If I show you a picture of Tiger Woods, you know, oh, that's Tiger
Yeah.
Woods, right? You're like, oh, there's the big guys, right? You know, the statues in this thing, right? Tennis players, you name it, right?
Yeah.
Why the hell do we not know who invented the language, right? I mean, this is a really low bar. It's like, I only use this language every day, but I have no clue who it is or what they even look like. You should be walking on the street, you see one of these guys like, hey, and stop everything, right?
I guess it's because I always consider those massive groups who created it and not just a
No,
one
it's,
person.
it's like Bill, here's Bill, right?
Yeah.
So this guy, Linus says, thank you, that's a hint. Thompson. Linus is Linux's. And so Linux is basically a port of Unix,
Yeah, Linux has so many applications.
right? Likes coffee, that should be pretty straightforward.
Java, yeah.
Fastling, right?
Yeah.
All right, this one's much more important. So if you guys understand this one, this will make a lot more sense. If you don't get this right, you will get this right very soon.
Different.
So he grew up in Chicago then.
No?
No.
Okay. He invented Robotron, Defender, all kind of video games.
Oh, this is.
First of all, Robotron is the best game ever invented.
Robotron.
And our school
Guy.
is getting renamed after him. So it's Eugene Jarvis.
Oh, I
Was
saw
he the
the
one that
email.
donated
I saw
the, like,
email.
50 million?
Yes,
For the new student
I
center,
literally just.
because they're rebuilding this whole building, right? Isn't that the whole thing?
well, his name's on the door.
Yeah. No, I heard that he donated like 50 million or something, and
I'm sure he did.
they're like, oh, we're gonna build a new student center for CDM students. Oh, where are you gonna put that?
Yes.
Anyway,
That's the
so
question.
our school's gonna be named the Eugene Jarvis, College of Computing and Digital Media.
Huh.
I worked with him for 20 years.
Damn.
But if you played Robotron, it's seriously the best game because you have two joysticks. One is moves the character, the other one moves your weapon, you shoot in 8 directions. So you have to have your brain moving one way and your other half of your brain going the other way. It's horrible. It takes forever to do it. And right when you pass the first 2 or 3 waves, you can flip the game around there. And so like it was safe to stay in the center, but if you're in the center now, you're dead. You have to be on the wall. So like your whole logic flips. And it's like kids dig it. So
Kids.
there you go. All right, let's do a break.
It's cheap. Cheap food.
And other.
cheddar cream and sour, cheddar and sour cream. Cheddar cream and sour cream. Ouch.
Should not have eaten them with lunch, I should have saved them for like right now. Cause I don't like lunch, I was like, "Ah."
That's why we put it on the 7-Eleven.
I don't want to spend money though, like. I really just feel like Costco snacks.
What's the Twitter mom upset with today?
Elon Musk. The freaking whiteboard right there. It is so- Was that there last week? I feel like it was. It's not.
Interesting. And that's actually- What?
Last week, when Carol dropped us off, right? Turns out I went home later. I think it's because we should have walked so far away. I swear, because we left a lot earlier than the week before that. But I ended up getting home like 20 minutes later. I'm
I see you just missed the train cycle.
No, it was 100% like we were walking, like, it was that and because we were walking. It was like,
We walked for like 5 minutes.
yeah, 5 minutes.
You'd be waiting at the train station for 20.
True.
You got there in like 15 minutes.
I don't know. I just remember it definitely being like. Like that week I had a pretty good cycle. I didn't miss the first yellow line I got. If you remember the yellow line, you got like 10 more minutes. For one. That's Krusty Kreme. Krusty Kreme. Oh my God, this shit does- It's corn is the hardest it's ever gonna do. Corn is-
It is the hardest. It's also worth the most.
I know, that's why it's pissing me the fuck off.
That's a pain, yeah.
I think I don't think I'm gonna get much by Saturday night. Gotta turn in whatever the fuck I have.
You can always read.
Come back
you
later.
can always- Yeah, you can always resubmit, and if this one's very that easy, you can resubmit this week.
Right, and try to just work at it.
Yeah.
I think PA4 is gonna be one of those things that like, if I finish any other homework this quarter, I'll just work back at it. Because I don't know, I just don't know what I'm missing, man. I just have that feeling like once I get 4 and 5 working, I'll be able to maybe get a couple more working.
Well, yeah.
Well, 5 is, once you're done with 5, that's when you start doing the coalescing.
Yeah.
Well, 5
Or
is.
5 has one case of coalescing, but
5 is one case, this case is one. Yeah, it's case 1, right?
yeah, case 1, close to the bottom, yeah.
You have the case 2, which is a bit harder, you have these 2 pointers, you have to actually set that on the.
Yeah,
above
test
three,
6 is case 2.
and then you
Wait,
get-
no, the test 7 is case 2.
Yeah, test 7 is case 2. And then you
Test
get
6 is just case 1, but
Case
it's going
1,
down, but coalescing,
case 1, the whole thing. is used.
well, because it's up and then case is down. Yeah.
So you-
At some point, it doesn't matter, you gotta do all the
Yeah.
pieces.
I mean, because at this point though, like once you're done with like 7, your code theoretically should be
You,
complete.
you tend to get after 7 or 8, you get like 3 or 4 like almost free.
Yeah.
I'm
You get the
hoping it goes
100%
fast
one,
after that.
you get the coalescing.
Because the next 4 just are massive tests of the same thing.
Yeah, it's just, I'm just checking edge conditions. If your logic's right, it should start
Get the
passing.
header above, get the header below, then do your lists, right? And it goes faster.
Well, then I could dock the point for like 0.4 milliseconds of speed. So bad. It's hot cold, it wasn't even jet house.
I think it's cool.
Like if you actually didn't hit that going.
I mean, I have a 6 out of 8 on it, so that's technically a 75. I can't resubmit the kid. I mean, yeah, but I'd rather work on PA or.
All right, so let's continue on. So we're gonna do proxies. Proxies is a more difficult concept of this week. This week's pretty lightweight. So this is the harder of the lightweight things. We're gonna do proxies. And proxies completely screw up people because they're overthinking proxies. Proxies is a surrogate, it's a substitution, right? So if I give you, if you go to a casino, they'll give you tokens, right? The coin is worth nothing, but in the casino, you can turn around and cash it and get money, right? So a proxy is, I'm gonna give you a token, you're gonna do something with those totokens, then at the end, you're gonna return it back to the right currency. Right? So proxy objects is an interesting way to manipulate code. Totally sounds smart using word proxies. It's Einstein's and Bohr's favorite C++ feature. They don't stop talking about it. It's one of their favorite. Totally not useful at parties, so don't even bring it up, right? So I was reading the Stroustrup book one day, and back when I started programming, there wasn't a lot of books. You guys are really fortunate books, but now I'm starting to see a side effect that there's almost too many books, and a lot of the books are crap. So that's why I have that list of links of good books up there. Those are books that I approve. But there's a lot of garbage out there. But Stroustrup is a C++ language book, and so I started reading it cover to cover, right? And it's pretty enormous. It's like 1,000 pages, right? And so I had on my version, I don't know, version 2 or something of the book, I had page 675, and it had this section called temporaries, copies, and loops. And this is where I found this stuff. So I was noodling through the book, and I came across this and I learned this stuff, right? So I was like noodling, I was mining the data. So noodle mining kind of came into my head. Then I remember all those years I worked in England, and noodle mining came there. So there's a movie.
Is Crumlin, jewel of the Welsh Empire. For beneath these hallowed hills lies fuel, not coal or oil, but pure pot noodle.
You learn a lot about yourself in a noodle mine.
I said more ventilation in the curry shaft, come on!
Selwyn Davis, I'm on the beef and tomato.
Deep below ground, the noodle miners must carve through sheer Welsh rock to extract the delicate noodle.
Our families have worked there for years. My first week! It's hard work working down in the noodle mine. This is where men are men.
So let us give thanks to Welshmen like Emlyn Evans, Idris Howells, and Llewellyn Caradog, for they keep going to keep you going. Pot noodle, fuel of Britain, isn't it?
So what's the odds of finding a noodle mining video, right? Well, it turns out the pot noodle is also the prize for the particle system. So if you are the best in the class for the particle system, I get you a bowl of pot noodle. So, you know, you can have trophies, you can have a diploma or 2 or 3, but the most prized possession you'll have bragging rights forevermore is this pot noodle. So I have, you know, I go out to the import store and buy it for every quarter. So if you win, you get the pot noodle. All right, so let's look at this. So let's say we had code as a vector, and we have, you know, a couple vectors here, and we want to do A plus B plus C plus D equals E. Don't ask me why. Let's say we just want to add these 4 vectors together and throw it in the third one, in the 5th location. From a temporary standpoint of view, it's A plus B is a temporary. Then temporary 1 plus C is another temporary. And temporary 2 plus D is another temporary. Then we write it into E. Right? But if we're going to write this in C, let's just screw C++ for a second. We're not overloading all operators. If we're going to write it in C, and you've probably heard of some companies and some engines are like going, our code's really fast, we write it all in C. Because it doesn't have the overloading, doesn't have the temporaries, it's a little bit leaner and meaner. Not as cool, but it can do the job. But if you're writing in C, you would write it this way. You would have some monstrosity signature that takes, you know, A, B, C, D, E. And then you would sit there and say, here's the E, here's the Y, and here's the Z. And so A, X, Y, and Z, and we're done. No temporaries. Right? So we go from 3 temporaries over here to no temporaries in C. And that upsets me, right? That's like going, my beloved C is losing to C, you know, its parent, right? So how do we improve this, right? So we can sit there and change our code. And what if we had this? What if we write our code such that this line of code goes presto changeo and lands right here, just to the body of this. And no temporaries, it's just boom, we're right into that location. Now we skip all those temporaries, the code will run a lot faster. And so what we're going to do this is we're going to manipulate the language and create our own pseudo language. And we can do this because we can use proxies. So you will never do this on all your code. You only do on something that you're used a lot in your system. So there's a lot of caveats, like this is a very weird time to use it. It's hard to use. You only use it when it makes sense, but when you do, it can improve things. All right, so let's do this. A plus B. The original function would be like this. Notice return value optimization. So we do A plus B, return the vector. But instead of returning vector, let's do another function that does this. It returns a temporary object called v add v, right? We can call it monkey, it doesn't matter. We can call it, you know, gym shoe. We just have to call it something. So because they're adding 2 v's, v add v, I just call it. And in this structure, we would define a structure this way. Now, I use structures and classes interchangeably. A structure is defaulted as public, a class is defaulted as private, but they both can have methods and constructors and, you know, and data. So here's our structure v add v. And here's our new add operation. So we can do it the old style, we'll call it style 1, or we can do style 2. And style 2 just says, add 2 vectors together, return a proxy. The proxy gets constructed right here. But then when you want to return a vector, we use the good old conversion operator. So the conversion operator does the converts these 2 guys, and does the vector add and returns the vector here. So it's a lot of presto changeo things going on here. When you add 2 vectors, we don't return a vector, we return a temporary or a proxy. The proxy is now just a proxy. If we want to return the original vector, we return it, we go through a conversion and converts it back to the original vector. Right? So I just won, I give money, right, to the casino, and I just play a casino game. I win tokens, then walk over and convert the tokens back to money. Right? So the token, if you open your eyes and close your eyes at the right time in the night, you never saw the tokens. You have pile on your money and you open up, you're in the parking lot with a lot more money, right? That's what a proxy is. Proxy is that intermediate temporary thing that's happening that never really is seen. We just see the end result. This is just a temporary way to optimize it.
So in your code on the right, you're saying that the vector inside the v is like the tokens, because the
Yeah,
outside
so-
interface
So it
sees money and the vector is the token.
Yeah, so here's how it works. You either have number 1 or number 2, but you don't have both. So if you're using number 2, you don't write number 1, you have to delete it. Otherwise it gets confused. It goes, hey, I have 2 vectors. Do I use choice number 1 or choice number 2? The compiler goes ambiguous and it throws up and fails to compile, right? So we're in number 2. And so all number 2 sees is this, A plus B. It goes, oh, hey, vector plus vector. Oh, look, vector, vector plus. There's my thing. It's not part of a class. It's just a floating function. So then what it does, it returns this temporary object, this proxy. And it passes an A1 and A2. Here's the constructor for that. So all it's doing is initializing this. This is now A, and this is now A1, and this is now A2,
And then
right? Then at some point you go, I want my vector back. Cool, conversion operator. I will now convert my 2 local variables back to a vector and return it.
it only does 1/2 of the original.
This is, we're just doing A plus B.
Oh, just A plus B on there.
Right? You'll see where we're going, right? So here's section A, and here's section B, right? So if there's only 2 variables, you're only doing a binary operation ever, you only do A.
Right.
If you are going to do more than 2 variables, you do B and more stuff. So you can't have 2 different ways for it to do it. It can either do A, vector overloading, or it can do function overloading, right? So if there's only 2, you only call section A. If you're greater than 2, right? And if you're greater than 2, and this is not there, that's the key, that cannot be there, then you can do B and C. Right? So let's see this right here. So here's vector, add vector.
And then that, like in mine doesn't really matter where it is because it's not part of the class.
Yeah, it's going to get substituted in.
Oh, because the compiler just
Yeah, the
takes it.
compiler's going
Oh.
to take this temporary and substitute it into this temporary, and then substitute this temporary. Hey, you want a vector? Convert it. And you, the vector, the proxy is there for compilation purposes, but it never gets executed because it just goes straight to the answer. So what this does is it goes this, and it's going to go from here. It's going to go, oops, oh, that was kind of cool, to here, which then goes to here, then goes to here, and then does this work.
So does operator, cause operator vec, does that get called by V of T1 and V? of
That's what
T2?
this line of code up here does. This says, I want a vector so I can do the assignment.
Oh,
So this becomes a vector.
and so you know that you need to call the operator,
So the compiler's always trying to convert,
right?
right? So let's code through this. This takes a couple times to kind of get it. All right, so you're at the top one here. So the plus operator here, it says, look, it looks at this function, goes, hey, here's a vector and here's a vector. So vector, vector, and an add. Cool, I'll call this function, calls this function. And what this is going to do is, okay. This is going to return a v add v. But this guy goes, I'm a vector, damn it. Like, fine, I will convert you to a vector. And now you can do the assignment. So it just lands in the v add v momentarily, gets converted back. So let's follow this out. So the plus operator returns a vector add vector. It's going to turn around, call this constructor, and this is going to be A1 and A2. These are references, so then this becomes A1, A2. Right? Then now we have this, a v add v, and this is a vector. We need to have, this has to become a vector. So now we need to convert this to a vector. Convert this to a vector. So we now call this function here and it does the conversion. And now this returns a vector. So
You
now,
have that, oh,
and now it's assignment as usual. Right? So we're never really, we have the proxy there in theory on the compilation side, but then it goes away. So even though you see this, we call A, it creates this, and then we do a conversion. Here's what the code really sees at the end. After the compiler does its optimization, it goes this right to this line of code. No, that other stuff's there to make the compiler work, but what the compiler really returns is just the work. It never sees, if you put a breakpoint there, you won't see the proxy. It goes presto change-o, it goes away.
And is the word inline there just to help the
It's-
compiler?
It helps the compiler
Figure it
line
out.
Yeah,
Okay.
and that's what reduces it away. All right, so let's do 3. All right, so we take the first 2. It calls here, and this returns A and B here, and this is a V add B. Right? What is C? C is a vector. So now we need to overload a V add B plus a vector as another function. So now we create the one in the bottom.
V and V and.
We create the one in the bottom. So now it takes V add V plus V. V add V plus V. Now this creates a V add V, which then constructs those, which now this is now A, B, and C. Now all of this becomes a vector. And there's that work. And now we can equal it to E.
So here you provide 2 classes.
Yeah, this is 2 proxies. One proxy then feeds to another proxy. So take all your money, you get red coins. Then you like this gambling table wants blue coins, fine, I'll switch them to blue. Then it's like, okay, I'm done for the night, cash out, and I get back to cash. So there is temporary. and close your eyes and open your eyes at the right time, all you see is the cache. So if you open and close your eyes at the right time, this is what happens. This code here goes bingo right to that. No temporaries. Right? So A plus B gives you V add V. V add V plus C gives you V add V add V. Then V add V gets converted to a vector. And that takes the 3 parameters, right? So we can do a 4-element one. V add V, V add V plus C, V add V plus D, V add V gets converted to vector. And now you get 4 inputs and you get a return. Right? So this right here has 1, 2, 3 proxies. And if you think about it, it's a proxy per temp, right? Here's one temp. Here's another temp, right? And here's the third. So let's go back to the first slide of this before we got lost. That's easier. All right. With proxies, we can take this code here and go, and call that with no temps. There's the win. The proxies do not speed up anything. It's a transformative operation. Right? It just transfers from this line of code into, this conversion operator.
What's the practical usage of this? So if you
temporaries.
Huh? Okay. But can't you just call the vector addition when you have the 4 in your code, or is it?
Well, you're not going to be writing, you never write the C style code. You're going to be writing only C++ code.
So if you have a lot of.
All this is it. This is your line of code.
Yeah.
And it's going to, we call this a lot, or it's too slow. We can make it call that.
Okay.
And then it makes it faster. And by doing that, we remove the temporaries.
So it's the use it a lot. I mean, you have to use it
Yeah.
a certain number of time to be worth.
Right. And this is where,
Okay.
Yeah, we don't do this unless there's a complete need for this. Yeah.
So there is no like optimization practicality there, right?
There's, technically speaking, proxy is an optimize. We're getting an optimization benefit because we go from here into the C style line, and that's really fast.
So is it more
So-
optimized than C style code, or?
Well, we're going right into a RVO. We're going right into an RVO. So we remove these temporaries. So this temporary is, if you think about it here, you're doing, this is one addition. Let's say it takes 100 cycles, 100, 100, 100, right? To get to here. So 1, 2, 300 cycles, right? Instead of those temporaries, I can go right into the addition, which probably be, a lot faster. I can't give you numbers on that. Because we don't have those temporaries, and those temporaries are what hurts us. Right? So this is tricky. Now, remember, I don't know if I said this in this class or I said in another class recently. Every line of code that you see in here, I compiled and dragged and dropped into the slide. So it's workable code. So when you're looking at this code, you're like, my stuff's not working. Look at the slides. It's there. Right? So here, right. It removes the temporaries, it removes the copies, it only touches the variables you need. All the work is done in the converter, all of the work, right? You know, you can do this with any binary operations. You can do it with plus, minus, divide, times. It can retrofit into existing code. So even if your code later changes where you add another thing, you're like going, oh man, it's 6 and I only coded it for 5. It would just take the 5, reduce it back down to a vector, then it becomes 1 vector plus the 6th element. Then that goes in a proxy, which is reduced down to a vector. So it still works.
Right.
If you did this for 5 and your code later changes, we're only adding 3 of these together, it will just drop out at the 3rd stage instead of going all the way to the 5th stage. So you can hop off of this proxy train at any stop. You know, so mixed types, you can do this as well. That's what Strausstrup did. He did it mixed with vectors and matrices. So, you know, this is only done on code that is used a lot. You don't do this unless it's necessary, right? So that's proxies. Let me show you the homework. So, right. This homework is a little bit more complicated. There's a lot of little projects, so you have to fire off different solutions, right? So follow, when we're doing this, follow the PDF, and the PDF will kind of guide you through here. So, all right. So implicit conversion, right? Remember, we're going to prevent integers being converted to floats or something like that. There's 3 builds: a debug build, a release build, and a prevent build. The debug build is just there so you can look at it from timing. You don't do anything in that code. Release one, you don't do anything there. And prevent, you're going to prevent it. So I'm looking at how many compiler errors. So you'll grade it on, is the right compiler errors happen? So let's look at that. So here's.
So this is the one case where you want more compiler errors. essentially.
Not more, the right ones.
The
If you
right
do too
ones.
many,
But
it's
it was the right
wrong too.
ones.
Right.
Just myself, and I'm just.
Now, this one's hard to see. There's not much of a performance difference because we're on Intel processors. You switch this to a RISC processor, to a more advanced processors, you'll see the performance do more. So here's the debug, right? And in debug, we're saying it's 8% faster, right? So you see the code. So here's the code. You know, we just have all these functions that take floats, right? And here's the code that runs it. You know, and it's just, you know, setting things and getting things and doing things in floats, right? Nothing fancy here. So if we sit there and do it, you know, we get this performance, you know. So if it's all in floats, it goes this fast. If we pass it in integers and other things, it goes a little bit slower because it's converting. So here's a test. And we have 2 tests. We have the test that takes in all floats. That's the first, you know, test. The second test is, here it is, an integer, a character, a double, and they get converted here. So, you know, an integer is getting passed into it. An integer is getting passed into the set where it should be a float. So it's going to convert an integer to a float, or a double to a float, or a character to a float. And when we look at this number, there's not much difference because it's in debug, and it's just not really that much different.
Yeah.
Then we go to release, and it's 50% faster. That's not bad. So guess what? Even on an Intel processor, if it wants a float and you give it a float, that runs faster than passing an integer. It converts a couple cycles to a float. So 50% faster is definitely okay. Then what you're going to do is you're going to go in here and change your compiler, your file. So you fire off the prevent option. And now what you're gonna do is you're gonna modify the header to make all those things private. So. And now you're gonna change this code here, monitor this file to generate errors. And you just modify it and it's gonna and spit out the errors, and then my grading just looks at which errors they are, make sure they're right errors.
Do we like know how many times it needs to be called? Is that in the PDF or is it just?
We can call it just, all you're doing is just changing this file and it
That's it.
generates
Oh.
errors. That's it.
Oh, cool.
There's nothing more. Yeah,
This is 3 lines of code, right?
whatever you think it is,
Okay,
right? And probably not 3,
okay,
but it's not more than, not many.
okay.
But you're just gonna change this, remember? So our technique in the lecture was you add the templates.
Yes.
You add the templates. So you'll add the templates to prevent the public methods from being screwed up. Okay, so now that's all you do. All right, so now let's go to the next problem.
Okay, it's 6.
I mean, like I said, this is a little bit of breather. All right, and do not, please, just for the love of God, or at least love of me, don't sit there like, I got 27 errors. Is this correct? You know, or here's the errors. Well, I got this many. And then all of a sudden, it's somebody that looks on Kaz like, well, there's the answer, right? So don't do it, but you know, it's easy to compromise this, but you know, see if you can get it right yourself. All right, return value optimization. I'm gonna give you 2 configurations. Debug and release. You're gonna open up the debug and you're gonna rework it here. Do all your work in debug. And if you do it, you're changing .h and .cpp. And then when you run debug, debug goes faster, and you run release, release goes faster, right? So let's do that. So RVO, here's debug. Like I said, this is a fun one or easier problem, so you're not going to be stressed out as much about this. All right, so here's RVO. So here's the code. Convert these methods to use RVO, right? And here's the code. Convert this to RVO. Like that easy, nothing more. You're gonna convert this, right? Follow the instructions from the PowerPoint. The results are pretty good. So here's RVO. In debug, it goes 2 times faster. You know, that's not a lot of code changes to make this go faster, right?
How many? There's a lot of loops to.
I mean, it's 2 times faster. Okay. I have to loop it many times to make it a mass, otherwise
To be able to measure. Yeah.
right. But it is 2 times faster. In release, right? It's not as good. And the reason for this is no RVO. The compiler keeps getting better and better and better and better. So the compiler, you know, Sutter is like going, oh, you know, you can do a name RVO optimization here. Like, don't do it, Sutter. You're breaking my class. But you'll still get an improvement, and that's a real improvement. So the compilers, this class is this perpetual change of I teach you tricks, and then Sutter tries to like have the compiler, you know, outdo my tricks. So we're fighting all the time. Right, so that's it. So this is pretty easy. We see that it increases. Remember, RVO only works, I can't stress this enough, if you define the copy constructor. If you don't define a copy constructor, it doesn't work, right? And some people are like, well, my times aren't good. Well, that's probably because you didn't do the copy constructor. All right. The next one is proxy objects. Right? It's debug and release, and open up debug and do all your work in proxy. Right.
What's the one where we have to like do all the compiler with settings?
That's the last one,
Oh,
the benchmark.
oh.
So here's the proxy. You want to do the other one? I don't care.
No, it's fine.
Here's benchmarks. We'll do benchmarks because that makes sense to you. All right, so here's benchmarks. There's 3 configurations.
Fast.
Debug, release, Mr. Fast, right? And what I do is I give you debug. You don't change the line of code. You just, there it is, debug. Here's release. You don't try to change anything. There it is. Then what I did is I copied release and I called it Mr. Fast. So you just use this. Or if you want to think about it, MR was from Midway runtime. So it's Midway runtime fast. We'll throw back to my old days at Midway. All right. And so what you're gonna do is you're just gonna open up the fast configuration and you're going to noodle with all these numbers and make it faster. And you put the results. What settings did you change? Like it comes in, it wakes up default saying, this setting is false. And if you change it to true, just type in, hey, I changed the setting to true. So I know which flags you flipped around. Also, it helps you keep track of it.
Right.
There's two tricks that you cannot do. You cannot disable exceptions because it blows the whole thing up. And you cannot turn on AVX. What is AVX? You'll learn that next week. But the reason is AVX is a new optimization. It's a new part of a processor that's only in the newest high-end computers. This computer, all the labs here, most people don't have it yet.
All right.
It's coming, So if you turn this on, my computer will crash. So don't turn this on. You might have it, it's cool, but don't turn it on for me because it will crash. Right? So that's it. So again, all we're gonna do is open up fast, noodle with the settings, and record them in the text file. So here's the benchmark debug, fast, and release. So here's debug. And you see the code. I'm not hiding anything from you. So here's the source code. You don't get to control anything. It's all in do not modify. And so
Yay.
so it's running right now in debug. And running. Still running. So you get to tell yourself a story while it runs.
So are we able to use these tactics then, like with and all the other projects in the future then?
In the particle contest, yes.
Oh.
Well, you can use the RVO and all that stuff.
Yeah, but just
with
not
the compiler settings is only for the particle stuff. And then when you leave here, right? So look at this, create a bloated thing, takes 18 seconds. So it's a linked list from hot cold, takes 24 milliseconds to find. Here's some random math stuff, memory system. And then here is some math problems. So here's your time in debug, right? Same code and everything. And so now I run it in your release, you run a release, and I'm just going to show the results instead of us waiting. So here's debug. So here's the times. These two, created, these four things are the times, right? So this 18 seconds, 22, 2 and 9, right? Here's in release, 4.5 seconds, 24.5 and 1.
All right, a bit better.
So release really improved it a lot.
Yeah.
Right? Then you're gonna do it in fast. And here's your times, whatever they are, right? And you're gonna sit there and capture in the settings which changes you did. I took the user under code from unset and now it's no. So any flag you flip, just record it. So here's how you record the flags and do that. In fast, and you have to make sure it says fast.
Is this all through the console where we're changing this or?
It's all right here. I'll show you. So we go here, here's the settings. Put your code here. What changes here, just in the settings, right? So we're gonna go to this part, this line right here, right click and it says properties. Or you can go through project properties,
Alright.
right? So here's fast settings with 32, right? Anything from here down is fair game. So here's some, what do these settings do? Here's some more settings. Here's the settings and more settings and more settings and more settings and more settings. Right? And here's all the settings for the compiler switches. Right. Then here's the linker, all its settings.
And these are all documented in the links you had in the lecture, right?
Yeah.
So we can read and read and read.
And so here's all these, and you knock yourself out. And there's some other things here that are probably useless.
1.2 milliseconds.
And you try this out. Now here's where the rub is. Just like the real world. Let's say you were doing this at your company, right? How fast should this go?
Preferably all under a second, I'd say. Or like the ones that are above 4.
You don't know when you're done. Maybe
No.
this is as fast as it gets.
Yeah, but you don't know if you don't try everything.
Or maybe you can go faster.
Yeah, you don't know if you don't try everything.
So yeah, so the catch here is this is one of those things where you don't really know what successful is because the compiler might do a good job. So maybe the settings for release is really good for math, but it's not good for memory. Or maybe that's as good as you're gonna get in memory. Or maybe all of them could get a little bit faster, or suddenly maybe your creative loaded comes 4 times faster. Who knows? So you're gonna have to noodle with that. And it's interesting because everybody should be able to make the code goes faster just by changing the knobs, and that's free. You pay the sweat equity to learn those features and what do they do. And also, if you turn on this feature, it's in opposition to these 3 switches, so you have to make those switches are off. So there's kind of interdependency, they're not independent. All right, so now we go to the proxy. So here's proxy. Proxy has 2 configurations, debug and release. You do everything in debug and you just rework proxy.h and CPP. You can do, if you want, the data needs to stay private. You cannot make it public in any way. You can do all your work if you want to in the header, that's allowed. Excuse me. Proxies like headers because it does a substitution. So let's take a look at this.
Wait, can you explain that again? I mean, you normally want us in the CPP files.
Right, but the proxy isn't, the work is the work, meaning the conversion operator. That's all the work is the conversion operator. So that can be in CPP, but the rest of the structure and the constructor and everything has to, in the operators, all have to live in the .h because that's a substitute. You can't have your body of your proxy live in CPP because then it's going into real code and it goes back, and now that coin becomes a real coin instead of imaginary coin. So here, let me show you. So we do this in here in debug. So here's the proxy, and here's the CPP file. You're not going to do this one, so cannot inline this line of code here. If you inline this, you kind of break the whole concept of the proxy, right? So this is a forbidden thing. So what I want you to do is just write your proxies. So you write your proxies here, and then below this, you're going to add a lot of proxies there. V add V, right?
So they have to be included there so that
Yeah.
all the places that the operators are used, the compiler.
You can get access to and substitute.
Okay.
Right, so that's where it will kind of live. And so you do all that here and what I'm gonna say here. First of all, let me show the results. So in debug, no proxy, and we use proxy, it's a slowdown. Because it's substituting into these temporaries that we're getting no benefit. It's actually, each of those coins become real.
Oh,
So in debug, it's a slowdown. But in release, it goes faster.
nice.
What are we proxying? We are proxies a vector 2D. So here's our vector. And here's our, our functions. And where do I want to start off? And here's what we're doing.
Oh, but we can see like, is A, B, C, D gonna be,
They're all different variables.
are they gonna be like, is A gonna be like an int every single time?
No, these are vectors.
Oh, so that, I mean, oh, so they're all vectors.
Yeah.
We're not doing like multi.
So you would have to do a 10 element
10
division.
element.
So you have 10.
Oh, that's a lot of type.
It's not that much, but.
V at V and V at V at V, V at V at V at
Or you can
V.
go V2A, V3A, V4A, V5A.
Oh, wait, so you do,
Just
so you
shorten
need
the
one for like
names.
A plus A, then A plus A plus A, then, so you need one for each one.
Yeah,
Then what-
because it has a chain through this. If you do less, it'll work.
It's not fast.
You just won't get as fast and you might lose points on speed.
Oh, so,
So if you did 3, you only did 3, like I'm not gonna do all 10. It will do 3, evaluate back to a vector, then goes vector plus vector plus vector, then goes to 3, go back down.
what's the stop just from putting all of these into a single, like the add? Cause the way it is.
No, this is all different ones.
Right, I guess I'm
You can't
still.
change this code, this unit test.
Oh, no, I guess, no, I mean, cause like with the, cause you're returning the proxy. Why can't you just make the proxy take 10?
You can't,
Because it only works on a binary operation at a time.
Okay, I missed that, yeah.
Yeah.
Explains.
That's why we have the chaining it. We say the first
Oh,
one gets, result goes added to the next one.
cause then it takes the V add 1, then in a vector, then V add 2. V
Yeah.
add 3, okay.
All right, so you're gonna do all the work in the header. So this is where you add this. Right? And the code here, my code actually works.
The stuff you have
Proxy.
here. So this works already.
This works for a 3-element vector. So you can kind of see how it works.
you just go from that.
So that's the first two and the bad.
So A plus B gives you B add B, the blue,
Yes.
right? Then you have blue plus green, blue plus, so here, these two give you a V add V, right?
All right.
Then it's called V add V plus vector, right? Look, V add V plus vector.
And then in V add V, there's
Then it
two
becomes green.
values.
So then this becomes green. This becomes a V add V add
V.
Or
V, and then that gets converted to a vector.
Oh, I see. Cause then with there though, because the V add V still holds both of the original A and B.
Right.
And you just reference it.
And
Oh,
so here, this is A and B,
you're just sticking up
then-
those restrictions.
then we go here. This T1 is loaded, this T1.V1
Right.
V1 gives you A. T1.V2 gives you B, and then T2 is C.
So you're just putting a bunch of structs inside structs basically and just keep feeding it.
Keep going nuts. So here's 4. Right? And what happens, it gets this little heavy, so people tend to go V4V, you know, there's your ad.
Yeah, I would not want to do
V4,
V and V and V and V.
You know,
10 times.
V3V, right? You know, do whatever you want to do. You can even call it V2, V3, whatever, but give it a name
Yeah, just,
that makes sense to you.
yeah, just, okay.
And this way, but you're gonna be doing this and it keeps growing out. So in the code, sorry, you're gonna start doing this. So let's start one to kind of get you the idea of how this starts, right? We're gonna do the vector plus vector, right?
Yeah.
So again, what's nice here is the code I have here works, right? So let's do vector x vector,
So you need the inline.
right?
Now, is the struct still in the class or? is
So
it just-
here, no, it sits outside it.
Oh.
So you would have here vector 2D, right? So this becomes, here's our addition, vector 2D. Vector 2D. And then this is going to create a vector 2D. Vector 2D. Vector 2D. Vector 2D. Right? And this is going to return a vector 2D. And
All right.
all right, so sorry. All right, so here's our code. So now we have some issues here, right?
Yes.
It's screaming at the X. Why is it screaming at the
Does
X?
it need to be arrows?
No,
Oh, no, because it's,
because it's private, right?
oh, yeah, you can't.
Add your friends here.
It's a private.
You don't want to do get X, you know, V1 dot get X, V1, V2 dot get X. That will make it slow. So add your friends here, right?
Can you literally just
You
do?
go like this, friend.
Oh,
Wow.
And boom, they're clean.
oh, so friend just allows it to access private.
Yeah, remember, only friends can touch your private parts. So you're declaring like this vector here, this structure is my friend. Use it. Right? So what is this complaining about?
Do you need to do the like? Wait, is it because you have a semicolon at the very end? After the brackets down there? No, still you don't.
Right, sorry.
Let's see.
It's not a complete. Do you have to reference it? Or what you call, do you have to scope it? Even though you're out,
No, because you're already.
oh, because you're in this, no, it's just its own thing,
Scope is an H.
like 2D, like 2D. Expected.
Let's see.
Oh, did you not delete the original?
Here's the original.
Oh, it is there.
No other format. That friend got us out of there. What's happening here?
It seems like it's anything that needs to be imported or
What was the message you're saying? Missing?
missing a semicolon before the plus. Missing type specifier.
Let's just do a harder.
So it doesn't think it's a function.
not seeing this here.
It feels like a curly brace, maybe missing. Higher up.
Oh, wait.
No, because you're outside
No,
of the
no,
class, like
no,
you should be here.
Yeah, it should be outside the truck. That was.
So always
So-
needed
so
after
here,
this
The
truck.
class is defined, and there's a semicolon that said end of class. Structure needs a semicolon saying end of that,
It does, oh,
So it's.
yeah, all right, so now, boom.
that
Right.
works.
So now you kind of see now here,
And you just need 10 of those.
right,
That's much easier than I thought it was.
Yeah.
'Cause it's the same thing.
so now, we gotta go and release. That's where we'll see the speed increase.
Some smooth jazz.
Smooth jazz. Yeah.
It's common.
Look at smooth jazz calming you.
I'm saying like this.
All right, so here's the code.
Cause it makes me wanna like go with it.
So it's a little bit faster, that's with that one proxy, right?
Oh, nice.
So now the thing to do is here, if you wanted to, you can make this code here, if you wanted to be and see the CPP file. It's optional, you don't have to, but you can do that. So let's do that. Let's see what works, right? So we basically we're gonna cut and paste this into the file. CPP, because that's where the real work is. And we have a scoping nightmare, right? So now our scope is going to be structure. Oops. I think it goes here.
Yeah, that's how you should scope, man.
Yeah, there you go. And then
You'd get rid of
this
it there,
goes here, and wham.
and that runs a bit faster just because of that.
I don't know, but that's how you would move it over.
It depends.
See, it went slower.
Still
Yeah,
goes slow.
slower. So you're like, okay, well, that wasn't our friend.
Is it because you're?
It's calling out there, it can't do
Calling
as
out
much
the file.
inlining.
Yeah,
But try that, because once you get to the 10th one, it may change. It might be faster than CPP. This is choking because it's only adding two things together.
right.
So I wouldn't rule out the CPP yet. Yeah, so that's definitely, so that's how you do it. So add friends. Go nuts here, start expanding this, and you'll get there. So it's pretty straightforward, but gives you a big performance increase. All right, so any questions on this? So this is a lot of little things, so like 4 little problems. And like I said, it's, you know, kind of the breather after the part, memory system. Okay, basics 5. So basics 5 is debugging. And here's the solution. There's actually 10 projects.
Right.
So we compile this project, so let's compile project A, go this way. Go to A. And here's what's awesome about this assignment. You compile it. Clean, no errors. We run it. It failed. So this assignment is interesting. It's here's the class. Class has variables first and second. It has a constructor. It has 2 methods, right?
Right.
Then we look at the code here. It says do not modify. And it just has, okay, and again, here's the rules for this one. You know, modify, only change a.h. And here's the code. Initialize, get first, get second. So it runs the test and it fails. So the first one is 32. And the second one is, and we initialize with 32. 32 is getting passed in here. So here's 32. So second should be 32, and the first should be 32 plus 1. So first one should be the second one is 32, and the first one is the first plus 1.
What? But that's not what it said.
It's the other way around.
What?
Here. Start goes into second.
Oh.
32 is second.
Oh, okay, yeah, and then
Right.
it
And then
returns second.
second plus 1, so 32 plus 1 is 33.
Yeah,
So it should be 33, 32,
should be,
right? 33, 32,
but
Right.
it's.
but no, it's not that way.
I wonder what it actually, what is the value of get first there before it actually goes past the check?
The breakpoint,
Yeah.
right? So you look at data.
Yay, dereferenced. So first has no reference.
Right? So you get, we can go deeper into this and start debugging this, but
Yay, I love when I see that.
Right.
Well, because that's just dummy data.
so the question there is, and here's what's interesting about these problems is that everything compiles squeaky clean with the highest warning levels. And everyone's wrong. So now you get to learn how to debug. Right? So the whole idea is that you would look through this and follow the instructions, and the instructions here are go change a.h to make this work. And you go through, some of these ones are completely evil. They crash. They don't even like finish. They just hang. Some throw it as certs, throw sort of exceptions. Some are wrong answers. Some never finish. So but they all compile clean, squeaky clean.
Interesting.
Right. And then boom, this one's leaking memory and failing. Right. So the whole idea is that you have real systems to do this. The problem here is this is very hard to you have to do, it's 10 different problems, so you do 10 different debugging, so you just click on the one there. But how do you grade this? How do you know you're successful, right? You can click each one, run it, pass, turn around, click and run it, pass, run it, pass. But in the instructions, there's also a way to run all of them.
Oh, cool. That's actually
So
better.
this way you can just run them all. They have to be separate, for development purposes, but you can run them all. Every program needs to be run without debugging. So when we run it, we say run, it's inside the IDE. So IDE has all these safeties. But if you just look at the exe, if you just double click that, that's running without the debugger. So you have to run it without the debugger. So you have to do Control F5. So you might get one that like, hey, everything works. Then you Control F5 and like crash.
Yeah.
Because the Visual Studio is helping you and doing something. But when you use it in the wild, it crashes. So how do we do this? How do we test this? I'm gonna go to my solution one. There's you're basically gonna go this. You're gonna take this first solution here, not each one. You do the one that has the combo, and this combo has all of them, all the projects. And if you want to work on it like Project F, you just click here, right click and say set a startup, and now it's bold. It's hard to see, but it's bold. Now it will only run F. If you click here, right click, set startup, now it only runs A.
Oh, nice.
Right? But the reason why I give you this is not to do that. It's easier just to click the right solution one, is to build these all. So you just go to here, the top one, and you go in here and it says build, batch, and it says build them all. dook. And now it just builds all 10 of these.
Right.
So instead of you clicking each one, build, 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 now it's just building all 10.
So you can then just all text it, yeah.
Then you're gonna leave this and run an external script. And the script will run. So let me show you this. Okay, so that's done, so they're all built. We look in debug directory, there's all the exes.
Oh, nice.
Right? So there's right here, there's a debug script. And here's the script. Let's try opening it. There it is. And it says, just run exe and throw the output in foo. Throw the output in foo, right? And then I count how many tests pass. That's it. So it's really pretty brain damage, right? So ready? So I go 1, 2, 3, boom. And now it's just firing off. Done. And now I look at my output directory, and here's my output directory.
Ooh.
And here's 10 tests pass, so all 10 pass. Here's A, it passed. There's B, it passed. You know, right?
Oh, nice.
And obviously this is the solution, you know, a solution, so it's done. So now let me show you what happens with yours. You fire off clean me, boom, go back to the everything solution. Now we'll build it. So build it, you just go into the batch, and then select all, build. And these will all build cleanly. That's the problem with this. It's perfectly clean code. Highest warning level, tree warning is errors. And even with all that, your code can still be wrong, right? Right, so that's done. Now I'm going to run the batch file. You know, so through an insert, so you just go ignore.
Well,
Now it's hanging. So now you have to go task manager. See right here. It's going.
seems like it's just system 32. That's what the window is called. It's just that one. Oh, what? But that's what the window is called. Oh, yeah, no, okay.
No, that wasn't it. All right, we'll try this again. Abort, yeah, abort. Cool.
Does it close just because you want it? I know what is that? Isn't it?
It was working easier before.
You're saying the broken code was less broken earlier?
Oh, it's really broken. It's so broken. It's not even like failing for you nicely. It's failing with in a bad way. I don't know why it just killed shit. All right, what could go wrong with that move? All right.
So we definitely cannot just run it right off the bat, because it's just gonna.
I can run on my machine. I just keep hitting ignore, and it works. All right, so let's see. Maybe something. All right, so I think I'm relatively clean. All right, so we'll try this one more time. Here, and what I normally do is I just say board, I think.
Are you broken here because of your version check?
Oh,
I doubt it, no.
no, wait, no.
That only happens.
That would be in the compile?
Those search and errors can be for. Well, I've got like 20 of those, so. Had to figure out why.
And one more time, and then I try to board.
Try to
Um,
ignore it.
try ignore.
Hit enter maybe to like force it to pause. Well,
So it's really a good one, right? This one's the bomb. So
it's stuck with
it does compile. All right, so we'll do
Retry?
retry.
what? So compiles up to C, so D is what it's just dying.
I think it's choking at C.
It should
Oh.
be-
What is from G? Because it's not even starting D. No.
I think you're gonna have to fix C first. All right,
Oh, wait,
we're
no,
trying. I don't understand why. Oh, you know what? I wonder if I have to run it from one of the stupid shells.
Oh, Windows shell.
Yeah, what's that Windows shell thing?
PowerShell.
PowerShell, yeah. Let me try that.
PowerShell doesn't even like work half the time.
See PowerShell?
Yeah,
That's it, right?
yeah, that's it.
Yeah.
All right, cool. Now I gotta drive to the right directory. Don't leave, there's still a quiz. Kidding. I'm just getting ready.
I was so excited.
I heard somebody said that they gave a quiz once, I'm like, Jesus, we're not in high school anymore. Here we go. Basics, we're almost there.
Can you make that bigger, by the way?
Yeah, how do you do that? I think you can just.
Yeah, that does. Oh, yeah, that helps.
All right, now we try it, run.
Still.
No, now I think I hit, ignore,
Ignore.
let's try ignore first. It'll work.
I don't know. Doesn't seem like it.
Are we about to do the entire thing over again?
We're still in hell. Here's the PowerShell. And somebody's choking.
Comes within 20 minutes of each other.
Nope, that was the wrong one. 50-50. Right.
Whoa, what the? Oh, I know. You use one in front.
Oh, it's in the,
Oh,
whatever, it works on my machine really nicely. Anyway,
another reason why DePaul's machines are bad.
no, I think the solution there is just to make sure you
Actually do the.
make sure it compiles and runs and then disable if it doesn't work. I have no idea. I'll tell you, I'll demo mine and do a video record. What I'm doing, I'm hitting either abort or ignore and it runs.
Huh.
So, all right, so questions, problems, area, I mean,
Yeah, so on that basics, are we able to run, troubleshoot and fix them within Visual Studio?
yes, but you have to verify also by doing control F5 or control run outside the editor. So here, let me show you. So C is problem, right?
And that runs without the debugging help.
Right, exactly. So you would, here's C, we compile it.
I almost.
And C is the problem child, right?
Yeah.
So you go, you're going to do right here, debug, run without debugger.
Okay.
And that's gonna be the mistake. So see here it goes, keep, so it's hitting the memory, so it's corrupting the memory. You know, aboard.
So if you ran it with the debugger, would it tell you potentially what was hitting it?
Let's do that. There you go. Run it again. There it is.
Uh-huh. So it tells
So
you.
you know, you look at it from a different perspective, but as soon as you fix it, so it says right here,
Valid
heap.
address.
Whenever you see the word heap, you're in like deep doo-doo, right?
Yeah.
And it's saying, hey, you walked outside the heap.
Oh, God.
So like, you know, congratulations, this code is really evil. It walks outside the heap. So when we look at this code, and I don't even remember this one, so it'd be interesting to watch. Here's C. Oh, yeah, so this one,
Oh, it's virtual.
Yeah, so this one right here is fix the class to make it say hello, goodbye in appropriate language. So it starts off saying, the greeting is hello, and then it goes, ciao, return sheet, blah, 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 right? And how this works is you, the class here, here's the class, and then it has inheritance. It has the greeting. And then the virtual constructor is created and the virtual destructor is here. And the destructor changes the word greeting. So I know I'm looking at this now, I can figure this out, but you're something getting screwed up and it's not obvious from a code perspective. From a rules perspective, it's very obvious. So take a look at the stuff. There are 10 of these. I'll kind of get you thinking about debugging and troubleshooting a little differently. Look at the memory, look at the stack, look at run it in the debugger, run it outside the debugger. Some combination will give you some insight into this. We're talking about all these things are like a few lines of code to write. It's only like 1 to 3 lines to fix.
Yeah, I
They're
think I
not-
see it here.
Not that
Hours
hard.
to find.
No,
I think I
could
see
be.
this one.
So this is this format. All right, so any questions on PA4 anymore? I actually boxed out all the time thinking that you guys were gonna hit me with 1,000 questions and panicking and everything else. So either you guys are doing awesome or you're not at panic stage yet. And then Friday night, it will just explode on Piazza.
Hopefully,
Um,
hopefully people will use Piazza.
So stay with it, help each other out. You guys can get there. And remember, all PAs you can redo each one if you wanted to, and just the maximum grade is 70%. So even if you think you're like, oh, I'm going belly up on this one, all is not lost. Last quarter I had one student who redid them all because they was like, all of them and passed the class. I think it was a bit of a gamble to wait till and redo each one, but I think that person just needs 2 weeks to do each assignment. And so, they just ran a little long, but we were able to regrade it, they'll lose all that points, so.
Yeah.
But always try to get it done first time. So it's sometime tonight, sometime between 11 PM and 3 or 4 in the morning, I should have PA 3 and basic 3 graded.
Oh, cool.
So you see that, so it'd be pretty straightforward. So I just grabbed whatever the latest is and grade
Yeah,
it.
that's just a 5 out of 5 one, right?
Yeah, 5 out of 5 on that one, yeah. So hang in there. You're getting it. I'm actually, I have more confidence than maybe some of you guys have. Stay with it. How do you eat an elephant? This is my Indian friend taught me this one 30 years ago. 1 bite at a time, right? You're not gonna eat the whole thing in one sitting. You're gonna slowly eat the elephant 1 bite at a time, so. This is the
Say
elephant.
that, please.
You can office hours, you can work on any coding project at all, right?
Office hours is for this class.
Yeah.
Say that.
Yeah.
Oh, I thought you could.
Don't
schedule for
say
like
that
any
again.
question or anything.
Well, if it's general, a lot of times virtually nobody shows up, so I'm there for an hour and a half. It has priority for the
Yours is.
3:30 to 5.
I was looking at next semester and
Well, shoot some dozen questions, we'll see if we can get through this.
Yeah, I'm working on this for the AI
I'm
class.
gonna have to either.
Oh, for the AI class?
No, I'm project on, you saw it.
Oh, yeah.
Yeah.
Would I still get what? Yeah.
Yeah, so you getting, are you doing A-star right now?
No, we did A-star,
Yeah, it's 2
that was
One of
fine.
them must be in person.
We're
And the
doing
other one do
Minimax.
Yes.
Oh, shit.
As long
It's
as
the
you
one
are showing
for
that you're there,
Zero
so
games.
that you're registered for
Okay,
in
So we're
person,
doing dots
Yeah.
and boxes.
that your in-person class is in
So,
person, and that you have an
basically,
online class.
you have to.
It doesn't matter. Okay, that's good news, cause I don't wanna have to rearrange my whole schedule, cause
Something like that,
they're
like,
both
that makes
on
sense.
Thursday and I'm like.
Yeah, you're giving it cost.
Yeah, essentially, like,
That is
you-
for, that is for the fall quarter.
There's no actual. like,
Summer,
like-
summer's the
Summer
worst.
classes,
Oh, there is right here.
okay,
Oh, does it work?
that kind of changes a little bit.
All right, well, thanks, everybody.
The summer's like,
I have this literally
it's
in my.
split in
binder.
8 weeks and then there's 12 weeks, so I picked the 2 12-week ones.
Okay.
So that way I don't have to